Thanks. Check, check, check. Though I think we're not allowed to actually say the words BIP 100, so we might have to fire you as MC. Jeff Garzik, done Vegas Space Systems. I also do Bitcoin Core Dev for BitPay. And this is really sort of a laundry list of issues impacting block size proposals. It is not a comprehensive analysis into one specific issue, but many of the issues that are looked at as, I look at the next workshop as sort of output, looking at to generate proposals. This is input into some of those proposals. So a moment of history. Bitcoin was introduced as a P2P electronic cash payment system. That's what it says in the white paper, and that's what most of the users initially were exposed to. The 1 megabyte block size, as already covered, was set for anti-spam purposes. Otherwise, when Bitcoin's value is low, it's trivial to DOS the network with large blocks. So, moving on to some observations. The process of finding distributed consensus takes time. Therefore, by definition, Bitcoin is a settlement system. It settles on a stable timeline of transactions. The core service that it provides, in my view, is censorship resistance. If you don't have censorship resistance, you don't have a stable timeline. You don't have a permissionless entry and exit into the system. So that censorship resistance, in turn, comes from the large network of decentralized validators, nodes, etc. So average block size for all time is pretty much what that graph shows. We started to grow in mid-2012, and you can see in 2015, we started to burst up towards 1 megabyte. But in general, we see that blocks are, on average, not full. Block size provides DOS protection. That raises the cost of attack. Sort of a history, 250K soft limit existed until about December 2013, when it was bumped in the source code 0.8.6 to 350K. Then the soft limit was raised again to 750K in March of 2014. And you can actually see this on the block size graphs. If you, I didn't have a 2-year graph, but you can see pretty much exactly where Bitcoin went from 250K to 350K and on up. And that really shows that a lot of people just run Bitcoin Core with the defaults themselves. The trend is pretty clear that we're headed towards the 1 megabyte hard limit, but as mentioned, blocks are not full today. You know, that's caveated. We're excluding long blocks that take a long time for the network to find, and therefore more transactions build up, and that excludes artificial stress tests. So today, blocks aren't full. Observations about the fee market. We've essentially had, for the history of Bitcoin, mostly zero fee competition. Again, that's caveated. You have network events where you have long blocks that get full, traffic bursts, stress tests, and they're right before the soft limits were bumped. You would have short periods where there would be a little bit of fee competition, then it'd disappear. But on the long run average, so far, users have experienced essentially zero fee competition. The fee floor is set instead not by fee competition, but by the anti-dust, the anti-spam relay limit, which is encoded into Bitcoin Core. So essentially, you cannot get your transaction relayed unless you have this minimum fee set. And the miners, on the other hand, they're, you know, as miners' power is, welcome to mine any block at any, or any transaction at any fee level. But in practice, what matters is that fee floor set by the default Bitcoin Core, which is essentially leaving out dust. Fees provide near zero economic signaling today For users, it's incredibly difficult to reason. You have no idea when you're sending one Bitcoin whether your transaction is going to be a small in terms of byte size or large in terms of byte size. The value is not in any way correlated to the byte size of the transaction, and the byte size of the transaction is what the fee is based on. And so it's incredibly difficult to reason, and then furthermore, you might have a block that appears in a minute, it might, the next block might take 30 minutes, etc. And so they don't really have a good way to judge, am I going to pay fee X to get behavior Y? Because in the short term, the blocks are essentially unpredictable. So they're difficult to reason on the user side. On the miner side, pretty much the same way. Fees are unpredictable. You can ramp your soft limit all the way up to 1 megabyte to maximize however much fees you get, but essentially economically the fees are dwarfed by the 25 Bitcoin subsidy, and so it's just sort of noise. It's change to the miner, and it doesn't necessarily change their behavior through economic signaling. They can't perform some behavior which suddenly makes them more profitable. It's entirely dependent upon what traffic appears on the network. More observations, and like I said, this presentation is basically a laundry list. A non-contentious hard fork I view as a useful check and balance and a user voting mechanism. Hard forks in general should be hard and they should be rare, but I don't think that they should be impossible. Bitcoin was built to be upgraded. A natural equilibrium block size exists in absence of the limit. This is a bit of a controversial statement, and I'm happy to expand on that after the session. But essentially, there are several incentives outside of simply maximizing fees which will prevent miners from building large blocks, even in the presence of today's miner relay network, etc. Another observation, which a lot of people miss, is that there is rapid miner and mining pool turnover year over year. And so the market share for mining pools radically changes month to month, year to year. And similarly, we have people who are generating the hashes, and that changes from year to year as well. And so who is the king today is not necessarily going to be the king 6 months from now, a year from now, et cetera. And so that rapid turnover actually works against centralization because we have permissionless miner entry. Anyone can, assuming you can design a SHA chip and go to TMSC or another foundry and get chips, et cetera, anyone can mine at any time. There's no permission, there's no notifying anyone else, you just turn it on. So moving on to some problems, there's a wall at 1 megabyte. If we hit that wall at 1 megabyte, if blocks are consistently full on average at 1 megabyte, then that is a major economic policy shift to active fee competition. Now, as the previous slides mentioned, that is different from the entirety of Bitcoin's history where there has been basically zero fee competition. And so from the user experience side, that is a radical change. The users market software are not prepared for this. The user experience rapidly degrades once blocks are consistently full. Though helpfully the stress tests, the spam poured on the network did force some wallets to improve their fee behavior. So out of annoyance there is good. The wall at 1 megabyte creates a lot of market chaos as fees shift to a new higher equilibrium. And notably, this event is event-driven, not time-driven. And so we might hit that condition even before the next workshop, for example. And when we hit that wall, we have a problem where businesses, users are incentivized away from Bitcoin by high fees. More problems at a high level if you get stuck at 1 megabyte, as in we are failed to come to any sort of consensus at all, and it's incredibly difficult to figure out where to go from there, and we just sort of sit at 1 megabyte and never hard fork away. That strangles Bitcoin growth and adoption. Another problem at a very, very high level is what I call the fidelity problem. Fidelity is one of many, many Wall Street, et cetera, companies looking at doing some Bitcoin experiments. And they, like many, many others, they say, well, if I just flip the on switch with this beta program, I instantly max out Bitcoin's capacity. So that, number one, makes the project a non-starter from the get-go. If you're sitting there at 1 megabyte, business plans never get turned on, projects never get started, and that growth that you would hope to measure through observation in a block size never appears. So you get sort of a chicken and an egg problem where people don't want to increase block size until traffic is there, but people don't want to put the traffic there until there's some reasonable guarantee or hope that the Bitcoin bandwidth will increase. So that becomes the problem of, no user and traffic growth. If you build on it, then the block size problem sort of solves itself, and we all go work on Ethereum. More problems at a high level. Bitcoin was built to be upgraded, so we shouldn't be stuck at version 1. The protocol is upgradable through soft forks as well as hard forks. Soft forks are arguably both easier and a little bit more insidious in that they only require the miners to upgrade. They don't require any sort of user approval whatsoever. There is no good way in general to measure community opinion on block size. What if the vast majority of Bitcoin users want to stay at 1 megabyte? What if they want to go to 10 megabytes, et cetera? There's no good way to vote, no good way to figure out their collective opinion and then move on consensus from there. That's a duplicated point. Another problem that I see in a lot of analysis is not thinking about the user and market experience. There's various proposals, including an older one of mine, where you have, for example, a static jump in the block size or a static fall in the block size. And what that does is essentially reboots the fee market from scratch. And so from a market disruption and chaos standpoint, that's quite bad. Not thinking about the user and market experience in another sense is if we do nothing, as mentioned in the previous slides, a fee market will appear abruptly at the 1 megabyte blocks full consistently mark. Users are not informed about this, they're not prepared for this new economic policy. And so it is essentially just sort of foisted upon them in surprise. And sort of as an example of really not thinking about users in the market is there was a proposal on GitHub to restore the minimum fee rate to 10,000 Satoshis. And not getting into that specific proposal at all, but what in effect this does is that raises the minimum price to use the network once that is fully deployed in the default implementation. Good or bad, that's the net effect. And so you can't just say, well, I'm going to raise prices on everyone in Bitcoin, please merge this. There needs to be a lot more introspection and thinking about the user experience. Fee market specifically, there's a market disruption upon the shift to blocks full on average. Even worse than that is if you're going from today's state of not full to a full state, and then we bump to 2 megabytes, that's essentially rebooting the fee market twice. So you achieve a state where the fee market is active when blocks are full, you bump the increase, and then there's no longer block pressure. And so again, from a market perspective, it's just radical, volatile disruption. As mentioned, there's zero fee competition. That's potentially a moral hazard in that, is it sustainable long term? Right now, users essentially have low fees because the subsidy is economically much larger than the block fees. How long can that continue? And it is a valid economic choice to do that. Even though it's potentially unsustainable long term, it's quite natural to say, well, we want to subsidize adoption today and bring people onto the system. So that's a rational economic choice that many people can make. As outlined by many previous presenters, the limit increase has costs. There are a large number of them not listed here. This is just sort of a large summary. Hard fork required. A caveat is there is one proposal by Adam Back which doesn't require it, but most of the others do require a hard fork. Larger blocks potentially push miners and nodes off the system. System security may be impacted, and increased network load is shouldered by an ever fewer number of actors. More problems to avoid in block size proposals. Avoid high priests, otherwise known as core devs, choosing magic values. I believe that this should be transitioned to the free market and to a little bit more active role in that free market. Avoid user cliffs. This is what I mentioned previously, where you might have a jump from 1 megabyte to 2 megabytes. That is a large market change, which produces large market disruption. On the slightly more technical side, the Bitcoin core needs to send out blocks a little bit more smartly, in that right now it just sends out to every connection that requests it blocks at the same time, when a smarter algorithm would be a little bit more like BitTorrent and choke some of the connections, unchoke some of the connections, and you have a more optimal block sending system for the main network. This is not talking about the miner relay network. Another problem with this problem space in general is that you have centralization on the low end and the high end. And so it's a range that we need to find in the middle. What is the good value? On the low end, centralization pushes people to centralized websites once block space and fees demand it. And on the high end, you only have a few nodes that can process it, and you've essentially reinvented the Visa data center. And so we have to figure out where in the middle we are going to get. And another key problem in general is a lack of data and field experience on block size changes. Another observation, the community likes safety rails, notably sort of a floor and a ceiling, that sort of thing on block size. Simulations only go so far. Simulations are always not reality. Maybe stating the obvious, but field experience is potentially gained by a small change and then gather data, observe, etc. Speaking of simulations, these are some of the variables, not all of them obviously, that I've been running in some of my local simulations, just trying to get an idea for if you scale up the block size and then full nodes come down, prune nodes increase, etc. What are the network resource costs, the CPU costs, etc. Another thing I see is sort of analysis errors, analysis of block size proposals. A lot of this is discounting or not seeing externalities, and for example, that's where you might say, well, this miner is always going to maximize for fees, and that may potentially be quite erroneous, because a miner might have a private contract with a company to, for a fixed fee, publish all their zero fee transactions. Miners must be profitable in the short term. That's an analysis error. There's obviously debt-fueled miners, equity-fueled miners, etc. Miners quite often and quite rationally look at their long Bitcoin, and they look at, even if I'm losing in the short term, long-term Bitcoin's value will increase and I will make a profit in the long term. And so there are a lot of simplistic evaluations on miner profitability that I call sort of microscopic analysis. It's not really looking at the macro. And then another analysis error is the possibility of selfish mining implies a broken system, is that you can find quite a few individually selfish mining examples or incentives, but collectively they all break down. Is fundamentally once you have, and that's true with today's block size, that's been true throughout Bitcoin's history, is if 100% of the miners, or even greater than 50% are selfish, then Bitcoin's value diminishes greatly. So there are some some subtle incentives that keep things going, and some people are missing that in their analysis. Some more observations about potential changes. You have a static one-time increase in the block size. Problem, you need more forks later. If there's a static increase schedule, the increase might be too big for what the system needs, or it might be too small. That doesn't really take into account the free market needs. Feedback-based type systems, those reflect the market, but are potentially gameable and manipulated by someone who is just sort of buying a bigger block size, et cetera. Another potentially very interesting incentive-aligned proposal that appeared, I think it originated with Minnie Rosenfeld, I could be wrong, is pay to future miner, where you have, you insert a transaction that pays not to you, but it pays to some future miner, and so that's a random selection process at that point, and it nicely aligns incentives. In contrast, pay with difficulty scrambles the incentives because there's a lot of opportunity cost in either waiting for a longer block to make it bigger and giving up the opportunity cost of someone else finding a block before you, et cetera. You wind up having to either collude or potentially lose much more than you would gain by an increased block size.
Jeff?
Time?
We're out of time.
Uh-oh. All right, let me speed through it. 60 more seconds.
Let him speak. Thumbs up.
Okay. Second course correction, hard fuck. No.
That's it. All right. Thank you very much. Jeff Garzik, ladies and gentlemen. You want to finish the last thought?
Yeah.
Go for it.
I'll go real quick. A course correction hard fork is likely. Don't engineer too far in the future. All the world's coffees will not fit on the blockchain. You have to have layer 2 as well as increasing this and all the other scalability issues. And that's it. Thank you.
Thank you, Jeff. Awesome. Excellent.